This is my EightPuzzle program. I have the class node. Class node, it has all the value of the node. I create a board represent as a one-dimensional integer array, and its length is 9. And the list of child node, and the parent node, and index is the index of this array. And blank is the index of the value array of 0. And the length, cost, total cost, action is the for action up, down, left, right. And there's the constructor. Initialize all the value and set blank. Traverse all the board and find the 0 value is just 0, and I is the index of the 0. And we return set this blank as this index. And is expand child node. Index x, but this value is the blank's index. And we expand this child because we want to use this in the successor function. And so we copy the board to a new child node, new child list, and set all the blank and the current cost. So the new node of current child, we have the new current child, and set the cost, parent, length, and total cost, and then add this current child to the children list, and we return this node. Its goal is to check the result. Here's the goal array. We check it, return the true or false. And here's a hash map to check the repeat node. And this is a hash function, and those are the getter and the setter of the value. And the successor function class. Successor class is to represent all the move action. And so we create a new list called children to store the children node from the parent node, which means after all the moves. And this int x is the index of the blank node, which is 0. If we want to move left, we have to check this condition. This condition means the tile is not at the first column, so it can't move to the left. And move to the left, the index should -1. Move to right, check is not at the last column, and the index should +1. And to move up, index -3. Move down, index +3. And the BFS. For the BFS, I create a queue. So in the queue, we have the queue, and the time is the number of nodes popped off the queue, and space is the max size of the queue. So here we check the max size of the queue and got the time. The time increase 1 each time, and the getter set time. And here we add this initial node to the queue and check is not empty. So we remove this queue, first in, first out, and start time, and put in the hash map, use hash code to check is a go or not. And we go to the successor function and to apply all the moves and check the moves. And so if we run, we got the interface here. Choose the algorithm. I only build the first two. We enter 1 and choose the different level. Choose 1. So we got all the moves and the current node as an array, and the length, the cost, and total nodes. If we here, like move up, length is 2, and cost move up. Because we move 6, the cost is 6, and the total cost is 6. And then here we move right and move 2. So the total cost is 2 plus 6 is 8. And we got there's time and space.